Yeah. Yeah, we do now. What's the problem? We're gonna start off with an example problem. And this is from the homework set for 3.5, it looks like. And recall on 3.5, before break, we were doing rational function graphing. Which makes a perfect example. I was going to end up doing one of these anyways. This one will work just fine. So the question we're looking at is we have 4x squared plus 6 divided by x squared plus 2. So, and the problem is asking us to find all asymptotes. Vertical asymptotes, horizontal asymptotes, and oblique asymptotes, whatever exists. So let's just go through them one at a time. Where do oblique asymptotes exist? Sorry, not oblique. Let's start with vertical. Where do vertical asymptotes exist? Those are the ones on the bottom. The vertical asymptotes occur when the denominator equals 0. So let's set it equal to 0, and what do we get? I've got x squared plus 2 equals 0. I could subtract the 2 over and take the square root of both sides. And I get x equals plus or minus I root 2, which means no real roots. This graph does not cross x equals 0 or y equals 0. This graph never intersects the x-axis. Is that true? Yeah, it is true. Well, that's kind of crazy. Can I look at it and determine why that might be? Is there any way for this function to be negative? Is there anything in it that will produce a negative? The 2 is positive, the 6 is positive. X squared has a minimum value of 0. So the smallest this graph can get is if both of these are 0, and we end up having 6 over 2. So like the lowest this graph gets is 3. And that looks like is when x is really small. This sounds like it's pretty trippy. So we have no vertical asymptotes. How do we determine if it has horizontal or oblique asymptotes? Yes, the exponents match. The leading exponents match. So we're going to take the coefficients. So y will equal 4 over 1, which is 4. Which means we don't have an oblique asymptote. And we also never have it where it touches y. Well, x can equal 0. And we know the lowest value. Well, is it the lowest? I don't know. Let's plug in. If x equals 0, we have f of 0 equals 6 over 2, which is 3. Does it ever get any different? If I stick in f of 1, I get 4 plus 6 over 1 plus 2. That's 10 over 3, which is about 3.133 or 3.33. No, it's 3 1/3. Yeah, 3.333. Yeah. If I stick in 2, what do I get? What's going on? I've got 2 squared is 4. I've got 16 plus 6 on top is 22. And I've got 4 plus 2 is 6 on bottom. And this is 11 over 3. So it's getting larger. Does it get smaller anywhere? Let's check like 1/2. If I stick in 1/2, I've got 4 times 1/4 plus 6. And 1/4 plus 2. This is 7 over 1/4 over 9/4. So I'll multiply by the reciprocal. And I get 28 over 9. Which is 3 1/9. So even if I do a fraction, it's just getting closer to this minimum value. What it sounds like is we have a minimum, we could find the y-intercept just by doing 0, and we did. We've got a point here. When we get up to 4, it creates an asymptote. And it doesn't matter whatever I do is positive and negative does the same thing. Whatever I do, either positive or negative, is the same thing. If I stick in a negative number, I still get the same y value. Because they're squared. So it sounds like it's doing something like this. That's kind of crazy, isn't it? Let's take a look at this on Desmos. Let's see what Desmos says. I've got 4x squared plus 6 divided. Ooh. Look at that. It is doing that. Comes in from the left, dips down to go to 3, and then it goes right back up to 4. That's a crazy little graph. So in that problem, there's only a horizontal asymptote. Any other fun ones you wanted to try? That's it? All right. That was a good example with horizontal asymptotes. Let's give a try for another one. Let's go with f of x equals x plus 1 divided by 2x squared plus 5x minus 3. Let's figure out what we can about this graph. So we want to know asymptotes. We want to know the y-intercept. Let's see what we get from there. So we're looking at vertical asymptotes. We're looking at either a horizontal or oblique asymptote. Again, I can check for which kind of asymptote I'm looking for. If I look at these values in front. The exponent on the bottom is smaller than the one on the top. When we have an oblique one, the one on top's one bigger. Here, the one on bottom is one bigger, which means we're going to have a horizontal asymptote, and it looks like where this equals I'm brain farting here. I'm totally brain farting here. Let's see what we got. Oh, it should be 0. What am I thinking? I mean to finish that. I know it is 0. It should go to 0 because the top is getting bigger, slower than the bottom is getting bigger. So this fraction ends up getting smaller and smaller and smaller. I don't even need to finish right now. So this should have a horizontal asymptote at y equals 0. When it's not y equals 0, it's when these two have the same exponent. And when we have an oblique asymptote, it's when the top is one bigger. So we have a horizontal asymptote at y equals 0, which that's the x-axis. Which means as we go to infinity, it can't cross the x-axis, but it can locally. Where are the vertical asymptotes? Where the denominator equals 0. So I have A times C is -6 and B is 5. This looks like 6 and -1. It looks like we have a vertical asymptote when x equals -3 or 1/2. What else do we need? Y-intercept. How do we get the y-intercept? When what?
Like a 0 for x.
Yeah. F of 0. Anything with an x in it goes away, and we have 1 over -3. So the point 0, -1/3. And I think we're ready to graph. The x-axis is an asymptote. So when I draw it, I'm going to actually make it dotted right now, rather than drawing it solid. This is my x-axis, and it happens to be an asymptote. All right. We have the x-axis is an asymptote. X equals -3 is an asymptote. And x equals 1/2 is an asymptote. And the only point I have on my entire graph right now is 0, -1/3. Which looks like it's got to go down here. Because it follows an asymptote. When it goes left, it can't cross that. And it's got to go down like that. Question is, what happens on the left and the right? Well, here is 1. I can try f of 1. F of 1 is 1 + 1 over 2 + 5 - 3. Anything about plugging in 1 is that the squaring is really easy. This ends up being 2 over 4. And I know that simplifies, but still it's positive. It's 1/2, which means it's above the y-axis or the x-axis, which means it's got to do something like this. And I suspect -1 is going to do the same thing, but or -4, but let's give -4 a try. If I do -4, I've got -4 + 1 over 2 × 16 minus 20 minus 3. This is -3 over 32 minus 23 is 9. Did I do that right? This looks like it's negative. So it's got to be doing this. Yeah. Let's check it out on Desmos again. I'll leave that up on the screen while I plot this. Oh shit. That was scrub alert. I made a big mistake. What did I not do? There's something I didn't do. I didn't get all the intercepts. I only found the y-intercept. That's a fail. That's a huge fail. This was the y-intercept, but what about the x-intercept? Just because the horizontal asymptote is y = 0, that only applies at the edges. It can cross near the middle. And we know it does if we set this equal to 0. If I set that equal to 0, I could multiply through by the denominator and I get x + 1 = 0. X equals -1. That is my x-intercept right there. So this is wrong. And that's why that graph looks so funny to me. I'm like, why is it going the same direction there? There's no reason for it to. Which means we had this point and this point. It's this part's still going correct, and this part's got to cross here. And now it's not going to go back over the y-axis because it was our only zero. Which means it has no choice but to do that. AL. This is wrong. And plotting it confirmed it. Plotting it pointed out to me where I fucked up. So what's the lesson there? Double check your work, and just because we have a horizontal asymptote doesn't mean it never crosses it. We never cross a vertical asymptote, but the horizontal asymptote is only true when x goes to plus or minus infinity. We don't cross it way out there, but somewhere in the middle of the graph, we can cross it. You guys ready for more? Let's see, what else do we want to put up here? We have another problem. That looks like fun. Let's do that one. In fact, I'll let you guys start it and see how you guys do. Then we'll do it together. Slightly different than the one I'm looking at in both of them. I changed it just to make it crazy.
Is there a lot of people around Zoom?
There's 3 people. All right, let's see. How you guys did, what are we doing first? Someone help me here. What did you do first? You have a lot of things you could have chosen to do first, so. That's a good choice. What's the vertical asymptote? X equals 2 is the vertical asymptote. It's where the denominator equals 0, and that's at x equals 2. All right, what do we do next?
So.
Why?
There was. There was.
Oblique asymptote is correct. That's right. The top, the leading term on the top is 1 degree higher than the one on bottom. So this is going to generate an oblique asymptote. So we do synthetic division. So we're dividing x minus, or the -2 into 1, 0, -1. Don't forget the 0 because we have no x on top. What? Correct. Yeah, it's the opposite sign. So this is giving us x plus 2 plus some remainder, which means we ignore the remainder, and the oblique asymptote is y equals x plus 2. All right, so we got our oblique asymptote. Now what do we need? We need our intercepts. So the y-intercept was when x equals 0. And it gives us -1 over -2, which is 1/2. So 0, 1/2 is the y-intercept, or the x, y-intercept. What about the x-intercepts? How? Okay, that should get you to here. Should get -1 also.
Isn't there another step with the oblique asymptote?
What part?
The part where you set it equal to the equation to see if it crosses it?
Yep. That is one way, that's where we can check. It's a bonus. It helps make it a little bit clearer. Christopher's correct. So we can set the whole equation equal to our oblique asymptote and figure out what works here. And if we find something, it's where our graph crosses the oblique. So if I multiply the right side by x minus 2 over x minus 2. I get x squared minus 1 equals x squared minus 4. For x minus 2 over x minus 2. If I put these on the same side, like I add everything over or subtract everything over, I am going to get 3 over x minus 2 equals 0.
No.
Thank you. Another way to get this. Since I have a common denominator, I'm moving it over. I'm doing x squared minus 1 minus x squared minus 4 by subtracting the whole right side to the left side. Subtracting from both sides. So you see the x squareds go away. We got -1 minus -4 is +4. -1 plus 4 is 3. This never equals 0 though. It can never equal 0 because the top is never has it has no variable. The top is always 3. So it does not cross the oblique asymptote. So what do we have here? We have a vertical asymptote at x equals 2. We have an oblique asymptote at x plus along x plus 2. And we have some intercepts. We have -1, 0, 1, 0, and 0, 1/2. I'm going to extend my asymptote up further because I clearly didn't draw this well. And I don't want to redraw it, so I'm just going to write over the shit that's up there. This is, it's got to cross here, it's got to go there, and it's got to follow the asymptote. We know it never crosses it, so it doesn't go like above it and then come back and go downwards. So it's just going to follow it like a Tron cycle. Now, the other side, the right side could be above or below. Why don't we stick in x equals 3 and find out? If I put in 3, I get 9 minus 1 over 3 minus 2, which is 8 over 1, which is way up here. That's 4, 8 is like twice as high. Put it on, make it so I can see it okay. It's doing something like that. Ignore that point. And we can see that on Desmos. I graphed it real quick. Y equals x plus 2 is my oblique asymptote. I put it there so we can see that what it looks like. And we do have it going up as it goes to the right. I mean, I could throw in x equals 2. And if you want to show how to make that an asymptote, you click edit list. And you can click on these and make them dotted lines. Change the colors and stuff like that with that thing right there. So my asymptotes look good. And it doesn't look like my graph ever crosses it. Fun, right? Yeah. When you take the square root of a number, it's always plus or minus. Let me show you doing this problem another way. This factors into x plus 1, x minus 1 equals 0. Yeah, why not? Sure. X squared minus 1 does factor into this. This is a difference of squared. A squared minus b squared equals a minus b times a plus b. On the screen. So I can factor this like that. And clearly, when I set each of these equal to 0, you're going to see that gives me -1, and that gives me +1. So when we take the square root of a positive number, there's two options. Because the left side started as a square, we end up getting positive or negative. And you can always go back and check it in the problem. If I plug in -1 here, -1 squared minus 1, does that equal 0? Yeah. Just a little caveat of it. All right, almost 3 o'clock. We'll stop here. Unless you guys got any more questions. Start a new chapter soon. Isn't that exciting? You're done graphing this horrid shit. Well, if you're done with the homework. Stop recording.